Welcome to myprojectbazaar.com. Now I am going to discuss about title for this project. Our project title is a GA-based feature selection and parameters optimization for support vector machines. Now I am going to discuss about abstract for this project. Our project abstract is, first we take ultrasound images are implemented as an input. The input Gallstone images was taken in the format JPG or a PNG. The next step is pre-processing step. The image resizing and the image noise filtering will be done for the future purpose. After the pre-processing, we are segmenting the Gallstone region. The image segmentation is the process of partitioning a digital image into a multiple segments. The goal of the segmentation is to simplify or change the representation of the image into something that is more meaningful and easy to analyze. Image segmentation is typically used to locating the objects and the boundaries in the image. Then the segmentation follows in the steps of the image is segmenting using the level set algorithm and KFCM algorithm. Image features are basic for most of the real-time image processing applications. Edge is one of the prime features for the image. It helps us to analysis inferior and take the decision in the various image processing applications. In this process, the system uses a feature extraction based CNN algorithm process. This scheme is very effective. Due to the advent of a computer technology, image processing techniques have become the increasingly important in wide variety of applications. The image segmentation is the classic subject in the field of image pre-processing and also in the hotspot and focusing of image processing technique. Finally, classifying the Gallstone. In this process, we using the classification step by using the multi-SVM classifier is used to classifying the types of disease as well as the finally, the performance evaluation by meaning the accuracy specificity of the classifier is calculated. Now I am going to discuss about flow diagram for this process. First one is an input image. The first stage of any vision system is the image acquisition stage. Image acquisition is the digitalization and storage of an image. The basic step of the image pre-processing is to collecting the data sets and the input image. The computer graphically, the image scaling is the process of resizing the digital image, and scaling is a non-retrievable process that involving a trade-off between efficiency, smoothness and sharpness. The input images we are applying the filtering technique for removing the unwanted noises in the image. After the filtering, the result will be goes to the segmentation stage. In this process, we are using the two types of segmentation. First one is a level set segmentation and next one is a KFCM. So K means fuzzy, C means clustering is applied here. After the level set and the KFCM segmented images will goes to the feature extraction technique. When the input data to an algorithm is too large to be processed and it is suspected to be a redundant data, so then the input data will be transformed into a reduced representation set of features. Transmission the input data into the set of features is called a feature extraction. So in this process we are using the CNN feature extraction. CNN means convolution neural network. The features providing the characteristics of the input type of the classifier by considering the description of the relevant properties of the image into a feature space. If the features extracted are carefully chosen, it is expected that they will be extracted the relevant information from the input data in order to performing the desired task using the reducing the representation of instead of the full size of the image. Feature extraction involving the simplifying the amount of resource requiring to describing a large set of the data accuracy, and finally we are classifying the Gallstone. So here we are using the multi-SVM classifier. The train feature, label and test features are used here. The SVM model is a representation of the example as points of space mapped so that the example of the separated the category so divided into a clear gap that is as well as possible. Finally, we are calculating the performance estimation. The accuracy, sensitivity, specificity of the classifier is measured. The accuracy represents the efficiency of the process. The sensitivity shows how the algorithm given the correct classification. The specificity shows how the algorithm rejects the random classification results. The performance of the process is measured based on the calculating of the accuracy area under curve of the process. True positive, correctly identified. False positive, incorrectly identified. True negative, correctly rejected. False negatives, incorrectly rejected. So the accuracy, sensitivity, specificity is calculated based on the TN, TP, effort and the FP. Now I am going to discuss about output for this process. In this process we developed a MATLAB R 2017b version. First go to the current folder and select main.m file and click the run button to run our process. In this we are going to select any one input image from the dataset. Now I am going to select den.jpg image. In this process is detecting the Gallstone image from the dataset folder. The process is going on. In this process a contour algorithm level set is used. Level set and the FCM function is used here. Now I am going to select 2. The CNN feature extraction is done. Training and the test feature is displayed here. This is input image. This is pre-processing image. Here we resizing the input image. After the resizing we gives the applying the median filter for noise removal, and then level set is applied here. The level set is used to segmenting the affected region and the FCM is used to select the affected segmentation region. After the segmentation we extracting the test feature values using CNN. This is the level set segmentation and feature extraction. This is FCM image with test feature extraction. This is level set training feature and the classification is Bigman-Stone. And this is a train FCM features, and based on the training FCM features displayed in the Bigman-Stone. After that we finding the performance measures. Multi-SVM level set segmentation and the multi-SVM combination we achieving accuracy is 85% and its graph, and the FCM segmentation and the multi-SVM combination we achieving the 54% accuracy and this graph. Thank you for listening. Our demo is completed. Thank you.